So on November 9th, we captured some of the wildest images of 3I Atlas so far, showing jets of material stretching millions of kilometers into space. And in this video, we will explore Avi Loeb's analysis of these images and a huge problem with the math, because this object seems to be losing far more material than it should physically be able to lose. So the jets pointing toward the sun stretch about 1 million kilometers into space, and the jets pointing away from the sun stretch almost 3 million kilometers. The distance from Earth to the Moon is about 400,000 kilometers. These jets stretch about 7 times farther than that distance. What makes this even more amazing is that back in July, the Hubble Space Telescope captured this object and saw only a small glowing cloud around it. These new jets captured on November 9th are 3,000 times larger than what Hubble saw. Growing 3,000 times bigger in just a few months is absolutely shocking. Now, as you probably know, normal comets usually have one main tail that points away from the sun. This happens because of something called the solar wind. The solar wind acts like a giant leaf blower, pushing all the gas and dust from a comet backward at over 800,000 miles per hour. So seeing jets that point toward the sun and push against that wind is very unusual. For these jets to push against the solar wind and stay together for 1 million kilometers, they must be extremely dense and powerful. Now, antitails are rare, but they are not impossible for natural comets. Back in 1992, astronomers discovered a comet called Shoemaker, Levy 9, that passed too close to Jupiter. The planet's gravity tore it into 21 separate pieces. When those pieces hit Jupiter in July 1994, each one caused explosions that could be seen from Earth. The impact marks were bigger than our entire planet and stayed visible for months. Another example is Comet Holmes, which in 2007 suddenly became much brighter and created a huge expanding cloud. Both of these were natural comets that broke apart. That is likely what we are seeing with 3I Atlas right now. It may be a comet breaking into many pieces, with each piece creating its own jet of gas and dust. Now here is where things get even stranger. Avi Loeb calculated how much material these jets must be carrying away from 3I Atlas. The numbers are very surprising. He estimates that 3I Atlas is losing about 50 billion tons of material every single month. When objects travel through space, their path depends on their mass. By tracking how this object moves and how the sun's gravity affects it, scientists calculated that 3I Atlas weighs about 33 billion tons in total. So let's lay this out clearly. The total estimated weight is 33 billion tons. The amount of material it is losing each month is 50 billion tons. You would think it cannot lose 50 billion tons if it only weighs 33 billion tons. The math does not seem to work. But surprisingly, we have seen something like this before. When Shoemaker, Levy 9 broke apart near Jupiter, the total amount of material it released was much more than scientists first thought the comet weighed. This made sense once they realized it had broken into pieces. When the sun heats an icy object, the ice does not always melt evenly. The side facing the sun gets hot, while the other side stays cold. These temperature differences create stress inside the object. That stress builds up until the object breaks apart, like glass under pressure. When something breaks into smaller pieces, much more surface area is exposed to the sun. More surface area means more ice can melt at the same time. More melting means more gas shooting out in all directions. If 3I Atlas has shattered into hundreds or thousands of pieces, this would explain the 7 jets seen on November 8th and the huge multi-million kilometer jets seen on November 9th. Each small piece would melt and create its own jet. All those jets together could add up to the massive amount of material Loeb is calculating. But right now, we do not know for sure if 3I Atlas has actually broken apart. If future observations show that 3I Atlas is still one solid object and is still producing these huge, fast jets, It would be the first object we have ever seen that does not follow any known pattern. That would be extraordinary, and would require extraordinary evidence, because there is no way a solid object can lose more mass than it weighs. Another very strange thing about 3I Atlas is that it is traveling in what astronomers call a retrograde orbit. To understand this, imagine looking down at our solar system from far above the North Pole. All the planets orbit the Sun in a counterclockwise direction. Earth goes counterclockwise. Mars goes counterclockwise. Jupiter goes counterclockwise. Everything goes counterclockwise. But 3I Atlas is moving clockwise. It is traveling in the opposite direction compared to almost everything else in our solar system. Only about 1 or 2% of objects do this. Most objects with retrograde orbits are small moons that were captured by planets long after the solar system formed. Finding a large interstellar comet on a retrograde orbit is unusual. Even stranger, the path of 3I Atlas lines up almost perfectly with the ecliptic plane. This is the flat disk where all the planets orbit. Imagine our solar system like a plate. All the planets move along the surface of that plate. Most objects coming from interstellar space would arrive from random directions above or below the plate at steep angles. But 3I Atlas came in almost perfectly lined up with the plate. The chance of that happening by accident is about 0.2%. That is about a 1 in 500 chance. Have we seen something like this before? Sort of. Oumuamua also showed strange numbers and unusual behavior. Its shape looked very long and flat, like a pancake. Its brightness changed in odd ways as it tumbled through space. Most puzzling of all, it sped up slightly as it left the solar system in a way that was hard to explain using normal ice outgassing. Avi Loeb wrote an entire book arguing that Oumuamua might not be natural. He suggested it could be a light sail, like a giant solar panel pushed by sunlight. Most astronomers think Oumuamua was probably a strangely shaped comet made of hydrogen ice or nitrogen ice, which could explain the acceleration, but the debate is still ongoing. The difference is that Oumuamua was very small, maybe only a few hundred feet long. 3I Atlas is enormous, more than a mile wide, and weighing billions of tons. Finding something this large on such an unusual orbit definitely raises eyebrows. By itself, the fact that 3I Atlas is big and on a retrograde orbit does not tell us much. But when combined with the mass loss problem seen in the November 9th images, it makes this object one of the most fascinating mysteries astronomers have ever studied. If you enjoyed the video, please leave a like and subscribe so you do not miss future updates about space.